In this video, we're going to take a look at how a TI nSpire can be used to analyze bivariate data. To do this, we're going to use the document side of things, not the scratch pad. And I want to start by creating a new document. So I'm going to choose option 1 from the home screen. And I want to choose option 4 is where I want to start, list and spreadsheets. This is where we're going to enter our data. Let's say the values we are interested in are 0, 2, 5, and 7 in the first column. And in the second column, let's put 15, 12, maybe 11, and 9. And to give these a little bit of a meaning, let's say the second column represents a certain number of turtles sitting on a log, as turtles are wont to do. And the first column represents minutes. And so we have to be careful when we name things. MIN, notice that it's kind of italicized right now. If I type MIN, it becomes non-italicized because this represents, I think, like minimum, right? This is a function in the calculator. So I could either use fewer letters and just use M to represent minutes, or I need to use more and I could spell out minutes. So let's just go with M, and here we go. So we have a number of turtles sitting on a log in the sun. When they decide they have enough sun, and they drop off and go into the water. We start with 15 turtles at time 0, and then after 2 minutes, it's down to 12. After 5, 11. After 7 minutes, there's only 9. So to analyze this, we can start by creating a graph. And to do that, I want to add a new page. So above the doc key, there's a command in red, plus page. So I'm going to press Control and then the doc key and choose option 5. So I could either do that with the arrow key, or I could just actually press the number 5, is maybe a little quicker. And it gives me a screen that looks like this. I want to add a variable, right-click to add a variable. So here I'm going to add minutes as my independent variable. And on the y-axis, the vertical axis, I'm going to add turtles as my dependent variable. So some other names for these, we could call the independent variable the explanatory variable, and then the y variable is sometimes called the response or the predicted variable. So independent and dependent, or explanatory and response. So we can see a relationship here. It's a negative relationship. It seems, potentially, fairly linear. There's only a small amount of data, so there's not a lot to suggest that it's not linear, but here we go. So to do a little bit more analysis, beyond just this basic visualization, I can choose the menu key, and the TI nSpire is sort of menu driven. So when we're on a particular type of page, and I press the menu key, it brings up options that are relevant to that page. So we can maybe change the plot type or change the properties of the plot, action, whatever that means. We want to choose Analyze. And right now, I want to analyze by adding a regression line. There's different types of regression lines that we could add. We're just going to go with a linear regression line. So this is called the least squares regression line. And to quickly describe what that means, each point, we can compare the vertical distance from the point to the line. That's called the residual. And the idea of a least squares regression line is we want the squares of the residuals to be as small as possible. And there's something that's kind of cute about your calculator. We can go back to menu and analyze and choose residuals this time, the option down here, residuals, option 7, and let's choose show residual squares. And there we go. So these squares, the sum of all 4 of these squares, the one down here is so tiny we don't even see it, but the sum of the area of all those squares is the smallest possible for this regression line. And they actually give us this number. I don't know if we can drag this line at all. No, I don't think we can. That's okay. But the sum of the squares is as small as possible for this specific line. And there's actually another feature too. If we go back here, analyze, and choose residuals again, I can show the residual plot and we can see what that looks like. Sometimes if the data is curved more than linear, we might see that in the residual plot. It can help us see whether the relationship should be considered linear or nonlinear. The residual plot can sometimes make that clear. So, all right. So for us though, I'm not going to worry too much about the residuals just now. Let's go back here, back to residuals. I'm going to hide the residual squares, analyze, residuals, and hide the residual plot. So we're interested in sort of understanding this relationship a little bit more. I'm going to describe correlation and using the regression equation in a second video.